Hello coders, I welcome you all. In this video, we are going to discuss our next machine learning project, bank customer churn prediction using machine learning. Main aim of this project is to predict whether customer left the bank or not using available features. You can download this dataset from Kaggle or from my GitHub account. Link is given in the description of this video. So let's get started. As you can see here, to discuss this project, here I have mentioned some questions that you can see over here. So let's solve them one by one. So let me first import pandas as PD. We will import other libraries as per our requirement. Currently I am importing only pandas as PD. As you can see here, our pandas library is successfully imported. Now let's load our dataset. So I am creating one variable data is equal to PD dot read underscore CSV, and our dataset name is churn underscore modeling dot CSV. Let me execute this cell. I am going to press Shift Enter to execute this cell. As you can see over here, our dataset is successfully imported as a pandas data frame that you can see over here. So now our first question. In this question, we have to display top 5 rows of the dataset. So for that, let me write data which is pointing to our data frame here. And we have to use head method of pandas data frame. Let me execute this cell. As you can see over here, by default, head method is displaying top 5 rows of the dataset that you can see over here. These are our features: row number, customer ID, surname, credit score, geography, gender, age, tenure, balance, has CR card, means has a credit card, is active member, estimated salary, and our target variable exited. So these are our independent variables. And this is our dependent variable exited. So our target variable contains two values, 1 or 0. So 1 means customer left the bank, 0 means customer not left the bank. So this way we can display top 5 rows of the dataset using head method of pandas data frame that you can see here. So now our next question. In this question, we are going to check last 5 rows of the dataset. So for that, let me write data dot tail method of pandas data frame. Let me execute this cell. As you can see here, by default, tail method is displaying last 5 rows of the dataset that you can see over here. So by using tail method, also we can check total how many rows are there in our dataset that you can see over here. Total we are having these many rows in our dataset that you can see over here. So this way we can check last 5 rows of the dataset using tail method of pandas data frame that you can see here. Now our next question. In this question, we want to find shape of our dataset, means number of rows and number of columns available in our dataset. That we can do with data dot shape attribute of pandas data frame. Please remember, shape is not a method. It is an attribute of pandas data frame. Let me execute this set. As you can see over here, output is Python tuple. This is at index 0 and this is at index 1. So now let's display it in proper manner using print function of Python. Let me write number of rows, comma, data dot shape and index 0, and print number of columns, data dot shape 1. This is at index 0 and this is at index 1. Let me execute this cell. As you can see over here, in our data set, total we are having this many rows and total we are having this many columns. So this way we can find shape of our data set, means number of rows and number of columns available in our data set that you can see over here using shape attribute of pandas data frame. So now our next question. So in this question, we have to get information about our data set like total number of rows, total number of columns, data types of each column, and memory requirement. That we can do with just one method, info method. So for that, let me write data dot info method of pandas data frame. Let me execute this cell. As you can see over here, total we are having these many rows with this index. As you can see over here, column names and these many non-null values in this particular column. These many non-null values in this particular column likewise. And as you can see here, data type for each column. And as you can see here, D types column. In our data set, 2 columns having floating point data type, 9 columns having integer data type, and 3 columns having object data type that you can see over here. and memory usage for this dataset that you can see over here. So this way, using info method, we can get information about our dataset like total number of rows, total number of columns, data types of each column, and memory requirement that you can see here. So now our next question. In this question, we have to check null values in the dataset. If it is there, then we have to drop them. So for that, let me write data dot. We have to use is null method of pandas data frame. Let me execute this cell. As you can see over here, now it is displaying data frame with boolean values. Now let's perform sum of true values. Let me execute this cell. As you can see over here, output is 0, 0 and 0. Means in our dataset, there is no any missing value that you can see over here. So this way we can check for null values in our dataset that you can see over here. So now our next question. In this question, we have to get overall statistics about our dataset or our data frame that we can do with data dot describe method of pandas data frame. Let me execute this cell. Please remember, by default, this describe method is displaying statistics for numerical columns that you can see over here. Total, we are having this many numerical columns in our dataset. So let me take one column age. So count in this particular column. Average value in this age column. Standard deviation in this age column. Minimum value in this age column. And these are percentile values. 25%, 50% and 75%. Means in this age column, 25% values are below 32. In this age column, 50% values are below 37. In this age column, 75% values are below 44. And as you can see here, maximum value in this age column. Same you can check for remaining columns that you can see over here. So this way we can get overall statistics about our data set or our data frame using describe method of pandas data frame. If you want to check statistics for numerical columns as well as categorical columns, then here we have to pass one parameter, include is equal to all. Let me execute this cell. As you can see over here, now this describe method is displaying statistics for all the columns, numerical columns and categorical columns that you can see over here. So this way we can get overall statistics about our data frame or data set using describe method of pandas data frame that you can see over here. So now our next question. In this question, we are going to drop irrelevant features. So let me first display column names. To know, actually we have to drop which features. So as you can see over here, row number, customer ID and surname. So we are going to drop these three columns. If we drop these columns, then have no effect on prediction. So that's why we can drop these irrelevant features from our data set. So now let's drop them. So for that, let me write data dot drop and let me copy these column names and let me paste it over here. And here we have to pass axis is equal to 1 because we want to drop these columns. And to modify our existing data frame, let me assign back. Let me execute this cell. Now let's check top 5 rows of our data set. As you can see over here. So these columns are dropped that you can see over here. So this way we can drop irrelevant columns. You can see using drop method of pandas data frame that you can see over here. So now our next question. In this question, we are going to perform encoding of categorical data. As you can see over here in our data set, we are having columns like geography and gender having categorical values that you can see over here. So let me take one column, geography, to explain you the concept of encoding of categorical data. So let me display unique values available in this geography column. Let me copy this column name and let me paste it over here. And I am going to use unique method of pandas data frame. Let me execute this cell. As you can see over here, this geography column contains three values, France, Spain and Germany. Please remember, machine learning models can understand only numerical values. So we have to convert these categorical values into numbers. So please remember, main idea behind this is to encode France to 0, Spain to 1 and Germany to 2. So please remember, if we can do this, our future machine learning model can understand France is 0, Spain is 1 and Germany is 2. There is a numerical order between these countries. So please remember, our machine learning model interprets this order matters. But this is not the case. There is no any relationship orders between these countries. We want to avoid such interpretation. So we are going to convert these geography column values into binary vector. Means this geography column will be converted into 3 columns. Why 3? Because in this column we are having 3 unique values. If 4, then 4. If 5, then 5. So in this dataset, this geography column contains 3 values: France, Spain, and Germany. So we are going to convert these geography column values into binary vector like this: 0, 0, 1, 0, 1, 0, and 1, 0, 0. So now you can see here is no numerical orders. These variables are called as dummy variables. So to create these dummy variables, we are going to use get underscore dummies method of pandas. So now let's use get underscore dummies method of pandas. So let me write pd dot get underscore dummies. And here I am going to pass our data frame. So please remember, if we pass directly this data frame to get underscore dummies method, it will create one problem called as dummy variable trap. So what is dummy variable trap? The dummy variable trap is a scenario in which these independent variables are highly correlated. So in simple term, one variable can be predicted from others. As you can see over here, from this S and G, we can predict F. Likewise, so here with these two values, we can predict third one, right? So we are going to remove this first column, this one, to remove the problem of dummy variable trap. So to do that, here we have to pass one parameter inside this get underscore dummies method of pandas, drop underscore first, and we have to set it to true. To modify our existing data frame, let me assign back. Let me execute this cell. Please remember, just to explain you the concept of encoding of categorical data, here I have taken just one column, geography, but this is true for each and every categorical columns. So now let me check top 5 rows of our data set using head method of pandas data frame. Let me execute this cell. As you can see over here, our geography column is converted into 2 columns, actually 3 columns. But to remove the problem of dummy variable trap, here we have removed the first column that you can see over here. Now the values of this geography column is converted into binary vector that you can see over here. So this way we can perform encoding of categorical data that you can see over here. So now our next question. So now here let's check distribution of our target variable exited. I am going to use value counts method of pandas data frame. Let me execute this cell. As you can see over here. So it is always better practice to visualize it. So for that, I am going to use Seaborn library. So I am importing Seaborn as SNS. Let me execute this cell. As you can see over here, our Seaborn library is successfully imported. And I am going to use count plot of Seaborn. And here, let me pass our target variable exited. Let me execute this cell. As you can see over here, as you know, 0 means person not leaving the bank, 1 means person leaving the bank. And from this count plot, we can see that our data set is imbalanced. So the question is, what is imbalanced data set? Please remember, imbalanced data set refers to those types of data set where the target class has uneven distribution of observations that you can see here. So in this imbalanced data set, one class label has a very high number of observations and the other class has a very low number of observations that you can see from this count plot. So please remember, we have to handle this imbalanced data set. So we will handle it shortly. Please remember, first let me show you what happens if we do not handle this imbalanced data. Then after, we will discuss how to handle this imbalanced data set. So first of all, now let's separate dependent and independent variables. I am going to store independent variables in X. So let me write data dot drop, and let's drop our target variable exited, and here is X is equal to 1. Now let's check X. As you can see over here, these are our independent variables. So now let's store our response or target variable in Y exited. Let me execute this cell. Let me check Y. As you can see over here. So as I said, we will handle imbalanced dataset shortly. So now let's move to our next step. We are going to split our dataset into the training set and testing set. So for that, we have to import from sklearn.model_ selection, we have to import train underscore test underscore split module. Let me execute this cell. As you can see over here, our train test split module is successfully imported. So now let me write train underscore test underscore split. And here we have to pass our independent variables and our dependent variable. And I am going to set test size is equal to 0.20. So means we are going to keep 20% data separately for our testing purpose. And let me set random underscore state is equal to 42. So if you are using same number for this random underscore state, you will get same samples as mine. As you know, our data set is imbalanced. So in this train underscore test underscore split, we have to use one parameter, stratify is equal to y, our dependent variable. So please remember, in case with balanced data set, we can generate a train test simply by randomly assigning 20% of the data to a test set. However, in imbalanced data set, this should be avoided. There is a big risk of ending up with almost no cases of the minority class in the test set. So that's why here we have used this stratified parameter of this train test split. So what this stratified parameter will do? This stratified sampling will force the same class balance on the train and the test data set as the original data. So that's why here we are using stratify. So now let me assign it into x underscore train, x underscore test, y underscore train, and y underscore test. So here we have divided our original data set into two sets, one for training and one for testing. So we are going to train our machine learning models on this X train and Y train. We will test our model on X test and we will compare our predicted result with Y test. So this way we can split the data set into the training set and the testing set using this train test split. So now our next question. In this question, we are going to perform feature scaling, which allows us to put our features into the same scale. Why need to do this? Please remember, feature scaling is essential for machine learning algorithms that calculate distances between data. If not scale, the features with high value range starts dominating when calculating distances. The machine learning algorithms that require feature scaling are mostly k-nearest neighbor, neural networks, support vector machine, linear regression, and logistic regression. The machine learning algorithms that do not require feature scaling are mostly non-linear machine learning algorithms like decision tree, random forest, AdaBoost, Naive-Bayes, etc. Please remember, any algorithm which is not distance based is not affected by feature scaling. As you can see over here in our data set, these features are in different scale that you can see over here. So that's why we are going to put all the features into the same scale using standard scaler. So now let's do this. So for that, let me write from sklearn dot preprocessing, we have to import standard scaler. Let me execute this cell. As you can see over here, our standard scaler module is successfully imported. So now let me create instance of this standard scaler. Let me execute this cell. Now let me write sc dot fit underscore transform, and here let me pass x underscore train and let me assign back, and here let me write x test is equal to sc dot transform x underscore test. Let me execute this cell. As you can see over here, name x underscore train is not defined because I have not executed this cell. Let me execute this cell once again. So it was my spelling mistake. Now let me execute this cell once again. As you can see over here, let me check x underscore train. As you can see over here, now all the features are into the same scale that you can see over here. So this way we can perform feature scaling. Now our next question. So now from here we are going to use different machine learning algorithms for classification. As you know, our target variable exited having two values, 1 or 0, means this is a classification problem. So from here we are going to use different classification algorithms. Let me first use logistic regression. So for that, let me import from sklearn dot linear underscore model, we have to import logistic regression. Let me execute this cell. As you can see over here, logistic regression is successfully imported. Now let's create instance of this logistic regression. Now let's train this model, logistic regression. So here we have to pass x train underscore y train, our independent variables and dependent variable. Let me execute this cell. As you can see over here, our model is successfully trained. So now let's perform prediction. So for that, we have to write log dot predict, and here we have to pass x test, and let me assign it into y underscore pred 1 is equal to this statement. Now let's check accuracy of this logistic regression. So for that, we have to import from sklearn dot matrix, we have to import accuracy score. Let me execute this cell, and here let me write accuracy score. Let me press shift tab to check docstring of this accuracy underscore score method. As you can see over here, we have to pass actual values and predicted values. So in our case, actual values are available in y test and our predicted values are in y pred 1. Let me execute this cell. As you can see over here, logistic regression is 81% accurate on this data set. But please remember, our data set is imbalanced. So please remember, it is very dangerous to use accuracy as a metric on imbalanced data sets. So for imbalanced data set, we have to check precision, recall, and F1 score as well. So for that, let me import from sklearn dot matrix. Let me import precision underscore score, comma, recall underscore score, and F1 underscore score. Let me execute this cell. As you can see over here, these modules are successfully imported. So now let's first check precision score for this logistic regression. Again, let me press shift tab over here to check docstring of this method. Again, here we have to pass actual values and predicted values. So let me pass y underscore test and y underscore pred, our predicted values by logistic regression. Let me execute this cell. As you can see over here, 59%, and our accuracy was 81%. Now let me check recall score. Again, here we have to pass our actual values and predicted values. Let me execute this cell. As you can see over here, recall score is very low, that you can see over here, only 19%. Now let's check F1 score. Again, here we have to pass actual values and predicted values by our model logistic regression. Let me execute this cell. As you can see over here, F1 score is also very low. As I said, it is very dangerous to use accuracy as a metric on imbalanced dataset. Also, we have to check this precision, recall, and F1 score for imbalanced dataset. So now, what is precision? It represents the model's ability to correctly predict the positives out of all the positive predictions it made. Please remember, the prediction score is a useful measure of the success of prediction when the classes are very imbalanced, like in our dataset. Please remember, mathematically, it represents the ratio of the true positive to the sum of true positive and false positive. So we can write precision score like true positive to the sum of false positive plus true positive. So this way we can define our precision score. Now, what is recall score? Model recall score represents the model's ability to correctly predict the positives out of actual positives. Mathematically, it represents the ratio of true positive to the sum of true positive and false negative. So we can define recall score mathematically the ratio of true positive to the sum of true positive and false negative. Now F1 score. Model F1 score represents the model score as a function of precision and recall score. We can get these values of true positive, false positive, and false negative from confusion matrix. But here we not required because we have directly used these functions: precision underscore score, recall underscore score, and F1 underscore score. So we will discuss this confusion matrix in our upcoming projects. Now here, please remember, it is very dangerous to use accuracy as a metric on imbalanced dataset. Also, we have to check precision score, recall score, and F1 score that you can see over here. As compared to this accuracy, these scores are very low. So that's why we have to handle imbalanced dataset that we are going to perform next. So now let's handle our imbalanced dataset with smooth. So please remember, to handle this problem of imbalanced data, we can use two techniques: oversampling and undersampling. So when we are using imbalanced dataset, we can oversample the minority class using replacement. This technique is called oversampling. Similarly, we can randomly delete rows from majority class to match this with minority class, which is called undersampling. But the disadvantage of this undersampling is that we can lose a lot of valuable data. So that's why we are going to use oversampling technique. So we are going to perform this oversampling with smooth method. What is smooth? Smooth stands for synthetic minority oversampling technique, and it is one of the most commonly used oversampling methods to solve this data imbalance problem. Please remember, it aims to balance class distribution by randomly increasing minority class examples by replacing them. Smooth synthesizes new minority instances between existing minority instances. How it is doing this? Smooth generates the virtual training records by linear interpolation for the minority class. This synthetic one or more of the k nearest neighbors for each example in the minority class, right? Please remember, the advantage of smooth is that you are not generating duplicates, but rather creating synthetic data points that are slightly different from the original data points, right? So now, in short, we are going to make even distribution between majority class and minority class using this smooth, which is not there in our data set that you can see over here. This 0 called as majority class, and this is minority class, but we want even distribution between these two. So that's why we are going to use smooth to balance class distribution by randomly increasing this minority class examples by replicating them. That's all. So now let's use this smooth. So for that, we have to import from imblearn dot over underscore sampling. We have to import this smooth. Let me execute this cell. As you can see here, our smooth module is successfully imported. Now let's use this. So for that, we have to write smooth dot fit underscore resample, and here we have to pass our independent variables and our dependent variable that we have created over here, that you can see. And let me assign into new variables. So for that, let me write x underscore res and y underscore res. You can use any. Let me execute this cell. So now let's check this variable x underscore res, and let me use value counts method. Let me execute this cell. It is better to use on this y res. Let me execute this cell. As you can see over here, now we are having even distribution for majority class and minority class. This is just because of this smooth. So this way we can use smooth to handle imbalanced data set. So now let's split our data set into training set and the testing set. So in place of this x and y, we have to pass this x underscore res and this y underscore res. After this smooth, let me change it to x underscore res and y underscore res. So let me execute this cell once again, and here we have to remove this stratify parameter. And let me execute this cell once again, as you can see over here. So this way we can use smooth to handle imbalanced data. So now here our data set is split into two parts, one for training and one for testing after smooth. So now let me execute this cell once again, and let me execute this cell once again, and this cell also. Now let's use this logistic regression after smooth. Let me copy this. I'm keeping these previous results as it is. So let me copy this and let me paste it over here. Let me execute this cell. As you can see over here, accuracy of our model 79%. Previously it was 81. Now let me execute this cell once again, and let me create one cell below. Let me copy this and let me paste it over here. Let me execute this cell. As you can see over here, our precision score is increased to 76%. Previously it was 59%. Let me check this recall score. Let me copy, let me create new cell below and let me execute this cell. As you can see over here, our recall score is also increased to 81%. Previously it was 19% that you can see over here. Now let me create one cell below. Let me copy this and let me paste it over here. Let me execute this cell once again. As you can see over here, our F1 score is also increased to 79%. Previously it was 28% that you can see over here. So this way we can handle our imbalanced dataset that you can see over here using smooth that you can see over here. So now let's use our remaining machine learning models, because at the end we have to find our best model that we can put in the production. So now let's use support vector classifier, SVC. So for that we have to import from sklearn, we have to import SVM. Let me execute this cell. As you can see over here, our SVM module is successfully imported. Now here let me create instance of this model. So SVM is equal to SVM dot SVC, support vector classifier. Let me execute this cell. So now let's train our model. So for that we have to write svm.fit on x train and y train on our training set. Let me execute this cell. As you can see over here, our support vector classifier is successfully trained. Now let's perform prediction. So for that let me write svm.predict, and here we have to pass x test, and let me store this prediction into ypred 2. Let me execute this cell and let me check accuracy score. So here we have to pass actual values and predicted values by our model. As you can see over here, this support vector classifier is 85% accurate on this data set that you can see over here. Let me check precision score, our actual values and our predicted values. Let me execute this cell. As you can see over here, precision score is 84% that you can see over here. Also you can check recall score and F1 score. Now let's use our next classifier, k-neighbors classifier. So for that we have to import from sklearn.neighbors, we have to import k-neighbors classifier. Let me execute this cell. As you can see over here, our k-neighbors classifier is successfully imported. Now let's create instance of this classifier. Let me execute this cell. Now let's train this classifier using this fit method on x train and on y train. Let me execute this cell. As you can see over here, our k-neighbors classifier is successfully trained. So now let's perform prediction. So for that let me write knn.predict on our unseen samples available inside x underscore test, and let me assign it to one variable pred3. Let me execute this cell. Now let's check accuracy score for this classifier, k-neighbors classifier. Here we have to pass actual values and predicted values by our model. As you can see over here, this k-neighbors classifier is 83% accurate on our data set. Let me check precision score. Here again we have to pass actual values and predicted values. As you can see over here, precision score is 81%. So this way we can use k-neighbors classifier. Now our next model, decision tree classifier. So for that we have to import from sklearn.tree. We have to import decision tree classifier. Let me execute this cell. As you can see here, our decision tree classifier is successfully imported. Now let me create instance of this classifier. Now let's train our model. So for that we have to use this fit method on x train and on y train. Let me execute this cell. As you can see here, our decision tree classifier is successfully fitted on our training set. Now let's perform prediction. So let me write dt.predict on x test, and let me store this result of prediction into one variable pred4 is equal to this statement. Let me execute this cell. Now let's check accuracy for this model, and here we have to pass actual values and predicted values by our model decision tree classifier. Let me execute this cell. As you can see over here, our decision tree classifier is 79% accurate on this model. Now let me check precision score. Again here we have to pass actual values and predicted values. Let me execute this cell. As you can see here, precision score of decision tree classifier is 77%. That you can see here. So this way we can use decision tree classifier. So now next, here we are going to use random forest classifier. So for that we have to import from sklearn.ensemble, we have to import random forest classifier. Let me execute this cell. As you can see here, our random forest classifier is successfully imported. Now let's create instance of this random forest classifier. Let me execute this cell. So now let's train our random forest classifier on training set x train and y train. Let me execute this cell. As you can see here, our random forest classifier is successfully trained. Now let's perform prediction. So for that we have to write rf dot predict on unseen samples available inside x underscore test, and let me store this in y underscore pred file. Let me execute this cell. Now let's check accuracy score. Here we have to pass actual values and predicted values by our model. As you can see here, our random forest classifier is 87% accurate on this data set. Let me check precision score. Again here we have to pass actual values and predicted values. Let me execute this cell. As you can see here, precision score is 86% for this random forest classifier that you can see over here. So this way we can use random forest classifier. Now our next model. Here we are going to use gradient boosting classifier. So now we have to import it from sklearn.ensemble. We have to import gradient boosting classifier. Let me execute this cell. As you can see here, our gradient boosting classifier is successfully imported. Now let's create instance of this gradient boosting classifier. Now let's train this model, and here we have to pass our training set x train and y train. Let me execute this cell. As you can see here, our gradient boosting classifier is successfully trained. Now let's perform prediction using this model gradient boosting classifier dot predict, and here we have to pass our unseen samples, and let me store this result into ypred6 is equal to this statement. Let me execute this cell. Now let's check accuracy score of this gradient boosting classifier. Here we have to pass actual values and predicted values by our model gradient boosting classifier. You can see here this gradient boosting classifier is 85% accurate on this data set. Let me check precision score. Again here we have to pass actual values and predicted values. As you can see here, precision score for this gradient boosting classifier is 84%. So this way we can use different machine learning models that you can see over here. So now let's visualize our model performance. So we can select our best model that we can put into production. So for that, let me create one variable final data is equal to pd.dataFrame. I am going to create pandas data frame using Python dictionary. So here let me pass different models. Let me pass logistic regression, support vector classifier, k neighbors classifier, decision tree, random forest, and gradient boosting classifier. And let me create another key with name for accuracy. And here let me pass accuracy score, actual values and predicted values by our model that we have stored in y underscore pred 1 that you can see here likewise. So let me copy this and let me paste it over here. Total 6 times because we have used 6 models that you can see over here 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. And let me change it to ypred 2, 3, 4, 5 and 6. Let me execute this cell. So now let's check our variable final underscore data. Let me execute this cell. As you can see over here, random forest with accuracy 87% means this is the best model for our data set. So we are going to use this random forest in our production. Now let's visualize this data frame. So for that, let me import cbond as SNS and let me use SNS bar plot, and on x-axis let me pass final underscore data and models, this one, and on y-axis let me write final underscore data our data frame and this column accuracy. Let me execute this cell as you can see over here. So this way we can find our best model for our data set that you can see over here. In our case, random forest classifier is the best model for our data set. Same we can visualize our precision score. So for that, let me copy this and let me paste it over here. In place of this accuracy score, here we have to pass precision score. And let me check it to PRE for precision. Same over here. And let me execute this cell. So now let's visualize this data frame. So now as you can see here, this is our data frame for the precision score. As you can see over here, this data frame is showing models and precision score that you can see over here. Again, random forest classifier with score 86%. Also, we can visualize this data frame. So let me copy this statement and let me paste it over here. In place of this act, here we have to pass PRE. Let me execute this cell as you can see over here. So for our dataset, random forest classifier is the best model. So we are going to use this random forest classifier for our production. So now our next question. In this question, we are going to save our best model, random forest classifier. So again and again, training is not required and we can perform prediction using this saved model. Please remember, we have used train test split and we have divided our data set into two sets. One set for training and other set for testing. This is to evaluate performance of our model. But at the end, we have to train our model on entire data set. Then only we can put into the production. So as you can see here, after smooth, our independent variables and dependent variable available inside this x underscore res and y underscore res. And please remember, we have performed feature scaling on this x train and x test. So also we have to perform feature scaling on this x underscore res. To save our recording time, let me copy this statement and let me paste it over here. Here we have to write res and here is res. Let me execute this cell. Now let's train our best model on entire dataset, random forest classifier. So we have created instance as rf that you can see over here. So let me write rf dot fit on entire dataset x res and y res, our independent variables and our dependent variable after smooth. Let me execute this cell. As you can see over here, now our random forest classifier is trained on entire dataset. Now let's save our model. So for that, I am going to use joblib library. Let me execute this cell. As you can see here, our joblib library is successfully imported. So now let's save our model. Joblib dot dump rf, and here you can write any model name. Let me write churn underscore predict underscore model. You can write any. Let me execute this cell. As you can see here, our model is successfully saved. Now you can use this saved model for prediction. Now if you want to use this model, then we have to write joblib dot load, and here we have to pass this model name. Let me copy and let me paste it over here, and let me assign it to one variable model is equal to this statement. Let me execute this cell. As you can see here, now our saved model is successfully loaded. Using this instance, we can perform prediction. As you can see here, our column names, and here we can write model.predict. This one, model.predict. And here I have passed some random values for this credit score that you can see here, age, tenure, balance, likewise. Now let me execute this cell. As you can see over here, output is 1, means this customer can leave the bank. So this way we can perform prediction using our saved model that you can see here. So this way we can save our model, and this way we can perform prediction using our saved model that you can see over here. As you can see here, I have created GUI for our project exactly same way that I have created for our previous projects that you can see here. But here, because of categorical data encoding, here I have mentioned one field. So for Germany, user has to enter 1. For Spain, user has to enter 2. And for France, user has to enter 3. That you can see here. So now let's execute this cell and this as well. As you can see here, GUI for our project, bank customers churn prediction. Now we can perform prediction using this GUI. Let me show you this. So now let's enter this data. Credit score 619, age, and other features. And as I said, here we can pass value 1, 2, or 3. For geography, let me pass 1. And gender 1 for male and 0 for female. Let me press this predict button. As you can see over here, this customer leave the bank. Same over here that you can see here. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye bye. See you in the next video.